Good morning, my dear student. I am Dr. Subhadra Das from University of Engineering and Management, Kolkata. Today I will discuss some practical session related to engineering chemistry. So today my topic of discussion is experiment on determination of alkalinity of water. So what is our aim? Our aim to determine the alkalinity of a given water sample. So what is alkalinity? So from the term you can understand, alkalinity is primarily a way of measuring the acid neutralization capacity of a given water sample. In other words, its ability to maintain a relatively constant pH. Now, how this alkalinity coming in the given water sample? The possibility to maintain the constant pH is due to the presence of hydroxyl carbonate and bicarbonate ions that are present in the water. Some little bit amount of silicate and borate may also be present, but they are of negligible amount. So we are taking three major ions: hydroxyl, carbonate, and bicarbonate. So there are different types of alkalinity that may be present in the water. So first tell me, what is the difference between an alkali and a base? Remember, alkali is the base is that component that will react with acid. But it not necessarily the base should be soluble in water, right? But in case of alkali, it will react with acid, but at the same time, it will soluble in water. So all alkali are base, but all bases are not alkali. So there are different types of alkalinity that may present in the given water. One is coming from the dissolved carbon dioxide. One is coming from the carbon dioxide and bicarbonate. Next is bicarbonate and carbonate. And next is due to the hydroxyl group. So alkalinity, how you will measure it? As because you are measuring a alkali, so it can be measurable by simple acid-base titration. Like any acid like sulfuric acid, hydrochloric acid, you can use for titration. And you have to use two indicators. One is phenolphthalein and one is methyl orange. Why we are going to use two indicators? I will discuss in my future slide. So alkalinity of the sample can be estimated by titration of standard sulfuric acid or hydrochloric acid, and titration to pH 8.3 up to pH 8.3. The decolorization of phenolphthalein indicator will indicate the complete neutralization of the hydroxyl ion, the alkalinity due to hydroxyl ion, and half of carbonate ion. That is denoted by P. While to pH 4.5, if there is any alkalinity present beyond the pH level 8.3, that cannot be detected by phenolphthalein indicator. For that, you need a methyl orange indicator. While to pH 4.5, or sharp change from yellow to orange methyl orange indicator will indicate the total alkalinity. It will give the total alkalinity measurement due to OH minus, due to bicarbonate, due to carbonate, as it can measure up to pH 4.5. So that alkalinity you can denote by M. Now bicarbonate alkalinity is in between pH 8.3 to pH 4. For bicarbonate you need methyl orange indicator. For carbonate alkalinity it is in between 8.3 to pH 10. So bicarbonate alkalinity you can measure by phenolphthalein. And for carbonate alkalinity you can measure by phenolphthalein. And for hydroxide alkalinity, as it is beyond pH 10, at about pH 12, you can easily measure it by phenolphthalein indicator. Now this is the most important slide. So there are two types of alkalinity. One is caustic alkalinity, that is due to hydroxide ion and carbonate ion, and another is temporary hardness, that is coming from presence of bicarbonate ion. So alkalinity is a measure of ability of water to neutralize the acid. Now for OH minus alkalinity, as I have already discussed, OH minus alkalinity is in the pH range of beyond 10, that is at about pH 12. So OH minus will react with acid. We are measuring the alkalinity by reacting with acid. So OH minus will react with acid and it will give water. This alkalinity you can measure by phenolphthalein indicator. So next is carbonate alkalinity. 1 mole of carbonate will react with 1 mole of acid and it will give 1 mole of bicarbonate. But this bicarbonate again react with acid and it will form water and carbon dioxide. So only half of the carbonate you can measure by phenolphthalein indicator, because it for total neutralization of carbonate requires 2 moles of acid, right? So half of the carbonate falls in the pH range of phenolphthalein, that is between pH 8.3 to 10. Its pH range is 8.3 to 10, so you can measure it by phenolphthalein. But another half that is converted to bicarbonate, and bicarbonate is neutralizing the acid to form water and carbon dioxide. The pH range of this is around pH 4.4. So for this you need methyl orange indicator. So if you denote it by P, that is the Burette reading that is required for phenolphthalein indicator is denoted by P. P is hydroxyl ion alkalinity plus half of carbonate ion. Why it is half of carbonate ion? Because carbonate first converted to bicarbonate, it can be measured by phenolphthalein indicator, but the bicarbonate again react with acid and it is converted to water and carbon dioxide, that can be detected by methyl orange. It cannot be detected by phenolphthalein. So only half of the carbonate is getting half of the carbonate alkalinity you are getting by phenolphthalein indicator. So P is equal to total OH minus alkalinity plus half of the carbonate, and M, methyl orange can detect all the 3 alkalinities, so OH minus plus carbonate plus bicarbonate. So what is the method of analysis? For phenolphthalein indicator, first you have to take phenolphthalein indicator. pH 8.3 is the endpoint of the titration and it is measuring half of the carbonate and hydroxide ion. And total alkalinity you need methyl orange indicator. pH 4.5 is the endpoint of the titration and it measures all the bicarbonate, carbonate and hydroxide ion alkalinity. So what is the procedure? First we have to fill the burette with sulfuric acid solution. We will pipette out 10 ml of the sample in conical flask and add 2 to 3 drops of the phenolphthalein as indicator. The solution becomes pink because alkalinity is present in the sample. So as the sample is alkaline, the solution becomes pink. So now we'll titrate the solution, taken in the burette till the color of the solution changes to colorless, because all of us know that in acidic solution the phenolphthalein color of the phenolphthalein indicator is colorless. So now we will get the point as V1 ml and we will denote the point as P point. Now at this point we will add 2 drops of methyl orange indicator in the same solution. The color become yellow because half of the carbonate and bicarbonate alkalinity is still present in the solution. So continue this titration without refilling the burette, the solution of the color till it is getting orange red, because methyl orange is orange red in color in acidic solution. So note that point as V2 and it is the M point of your solution. Repeat the same procedure to get 3 readings. So this is the procedure. First you are taking the water sample, you are adding 2 drops of phenolphthalein indicator, you are filling the burette with sulfuric acid, then you are titrating. The pink color is becoming colorless, so it is the phenolphthalein alkalinity. Then you are adding 2 drops of methyl orange, the solution becomes yellow because it is alkaline. Then you are again titrating with the same sulfuric acid solution, then you are getting the reddish orange color. So it is your end of titration and it is, you are getting here the M point. So what is the calculation? For phenolphthalein alkalinity, I am showing it. The methyl orange alkalinity is same as this. So you are taking the volume of the sample, it is 10 ml over here. Burette reading for phenolphthalein, you are getting a burette reading over here. You have to take 3 successive readings. Then you are getting the average. So indicator is phenolphthalein. Disappearance of the pink color is your end point. Now the burette solution, in burette you are taking the sulfuric acid solution. So one point you have to note that it's practically impossible for OH minus and bicarbonate to exist together, because OH minus and bicarbonate will react with each other and form carbonate. So ultimately you will get the carbonate alkalinity. So it is impossible that 3 ion OH minus, bicarbonate and carbonate present in the single solution. So total alkalinity in the same way you will measure, but you will use the methyl orange and the solution color change will be yellow to reddish. So this is the calculation part. Phenolphthalein alkalinity is volume of sulfuric acid. It is denoted by V1. Normality of sulfuric acid. 50 is your equivalent weight of calcium carbonate because you are expressing the alkalinity in the equivalence of calcium carbonate. As you are converting the mg to liter, you are converting. You wanted to know the alkalinity in 1 liter of water, so you are multiplying by 1000, and you are dividing the whole to the volume of sample taken. So alkalinity of calcium carbonate equivalent you are getting as x mg per ml per liter, x mg per liter, or ppm as calcium carbonate equivalent. In the same way, you can measure the methyl orange alkalinity also. Now I am showing you how you will do the practical. So here you will choose, first you will choose alkalinity as test. Volume of the titrate, that is volume of the water is 10 ml. Speed of the titrate, that is the speed of the sulfuric acid, I am taking as 0.6 ml. Normality I am taking as 0.03. Now I am taking the indicator phenolphthalein first. Now I am starting the titration. So see, it is pink color, it will turn into the colorless solution. So at the end point, the pink color will turn in the colorless solution. So the titration is going on with phenolphthalein indicator. So it becomes colorless. So I stop the solution. Now see, you are getting titrant is hydrochloric acid. In the burette, you are taking here the hydrochloric acid. Titrant used is 3 ml. That is hydrochloric acid is used as 3 ml for phenolphthalein. So your V1 is 3 ml. Here I have taken sample as well water. And pH is greater than 10. That's why we are getting the value with phenolphthalein indicator. Now I will change it to methyl orange. See, it becomes yellow. Again, I will start the titration. So it will become reddish brown at the end point. So reaction is going on. Color, solution color is still yellow. When it will be reddish brown, I will stop the solution. I will stop the titration. So, yes, now I am stopping it. See, here you are getting 2 point V1 and V2. V1 is your phenolphthalein endpoint, that is P. V2 is your methyl orange endpoint, that is 5.2. So again, I am returning back to my slide. So by putting over here, you can measure the by putting the value of V and M, that is the volumes of sulfuric acid. In case of phenolphthalein indicator, it will be V, it will be P, and in case of methyl orange indicator, the volume of sulfuric acid is M. So, and you will put the normality, what normal sulfuric acid or HCl you are taking. 50 is the equivalent weight of calcium carbonate, and 1000 is your multiplication factor for converting to liter. So by putting all the value, you will get the phenolphthalein indicator as well as the value for the methyl orange indicator. So thank you all for your patience hearing.